Imagine a person standing near the edge of a cliff, blindfolded. You tell them, take one step. Would they move? Probably not, because something is missing. You haven't told them the direction. So instead you say, turn around. Now take one step. Now the instruction is complete and safe. One step gives the magnitude. Turn around gives the direction. Only when both are given does the instruction make complete sense. This is exactly what a vector is. A vector is a physical quantity that has both magnitude and direction, and only together do they give complete meaning. Welcome to the first video in our Motion in a Straight Line series. In this video, we will understand distance, displacement, speed, and velocity in the most intuitive way possible. Let's begin. Now, let's consider another situation. You are riding a motorbike. You want to reach a shop on the right side of the road, but you are on the opposite side of the highway. We've all done this, especially while following maps. You reach exactly in front of the shop, but on the wrong lane. So now, what do? You ride to the next intersection, take a U-turn, and come back. Let's say each side of the road is 5 meters wide, so the total width is 10 meters. And the next intersection is 100 meters away. So you ride 100 meters forward, cross the road for 10 meters, and then ride 100 meters back. The total distance you traveled is 100 plus 10 plus 100, which is 210 meters. But what is your displacement? Displacement is the shortest path between the starting point and the final point. In this case, that is just the width of the road, 10 meters. So even though you traveled 210 meters, your displacement is only 10 meters. Distance is the actual path traveled. Displacement depends only on the starting point and the ending point, along with direction. That is why displacement is a vector, while distance is a scalar. Let's extend the same example. You started from rest, from 0 kilometers per hour. As you ride towards the intersection, you gradually accelerate and reach 50 kilometers per hour. Then you slow down to about 5 kilometers per hour. Take the U-turn and accelerate again. On the way back, you reach about 55 kilometers per hour and finally come to a stop in front of the shop. Now, throughout this journey, your speed is continuously changing. The instantaneous speed is simply the reading on your speedometer at any given moment. Every time you look at the speedometer, that value is your instantaneous speed. But what about average speed? Average speed is defined as the total distance traveled, divided by the total time taken. In this case, the total distance traveled is 210 meters. Let's say the total time taken is 2 minutes, which is 120 seconds. So, average speed is 210 divided by 120, which gives 1.75 meters per second. If we convert this into kilometers per hour, it becomes 6.3 kilometers per hour. So even though your speed reached as high as 50 or 55 kilometers per hour at certain moments, your average speed for the entire journey is just 6.3 kilometers per hour. Speed is a scalar quantity, whereas velocity is a vector quantity. Consider the motorcycle shown on the screen taking a turn at a constant speed of 20 kilometers per hour. Throughout the turn, the speedometer continues to read 20 kilometers per hour. So the speed remains constant. However, the direction of motion changes continuously from north towards west. Since velocity depends on both magnitude and direction, the velocity is continuously changing, even though the speed remains the same. Let us now hammer down our understanding of speed and velocity by solving one final problem. We know that speed is the rate of change of distance, and velocity is the rate of change of displacement. As shown in the problem, we have to find the average speed and average velocity of the tip of the minute hand between 6 p.m. and 6:30 p.m. The length of the minute hand is 4 centimeters. Between 6 o'clock and 6:30, the minute hand rotates through 180 degrees, moving from the top of the clock to the bottom. The path traced by the tip of the minute hand is shown on the screen. We also know that the journey takes 30 minutes. Let us first calculate the average speed. The distance traveled is the actual path, followed by the tip. This is shown by the red dotted curve. Notice that this path is a semicircle of radius 4 centimeters. The circumference of a circle is given by 2 πr. Therefore, the length of a semicircle is pi r. Substituting r equals 4 centimeters, we get the distance traveled as 4 pi centimeters. Average speed is defined as distance traveled divided by time taken. Substituting the values, we get the average speed as 4 pi divided by 30. This comes out to be approximately 0.42 centimeters per minute. Now, let us calculate the average velocity. For velocity, we are interested in displacement, not distance. The displacement is the shortest path between the starting point and the ending point. These points are marked by the blue dots. The shortest distance between them is the diameter of the circle. Since the radius is 4 centimeters, the diameter is 8 centimeters. The displacement is therefore 8 centimeters directed downward. Average velocity is defined as displacement divided by time taken. Substituting the values, we get 8 divided by 30. This comes out to be approximately 0.267 centimeters per minute downward. Notice the difference. The average speed depends on the actual path traveled, but the average velocity depends only on the starting point and the ending point. That is why speed and velocity are not the same quantity. And this is exactly why speed is a scalar quantity, while velocity is a vector quantity. Thank you for watching the video till the end. If you found this video useful, please take a moment to like and share it with your friends. And if you want to learn Class 11 and Class 12 physics through simple explanations, real-life examples, and intuitive analogies, make sure to subscribe to the channel. In the next video, we will derive all 3 equations of motion from first principles and understand where they actually come from, instead of simply memorizing them. See you in the next one.